All right, well, welcome. Um, this lesson is about how to find the resultant of two vectors or more. Um, and what we're going to do is we're going to find them geometrically. This is a very good method for some things, not so good for other things. So you have to learn all different methods to being able to apply them differently. So first and foremost, we have this point A, and we have these two forces. One force 1 going in this left direction on this point A, and then we have a force that's pulling this F2 in this direction 30 degrees from this 100 newtons, this force of 1. So what we're going to do is we're going to first and foremost draw a triangle. So we're going to solve this geometrically, solve this problem geometrically, and then from there you'll see a different way to do things than probably you're used to. So for most part, what we're going to do is we're going to rearrange this. And what we can do is we can, what's called, we're going to change, and we're going to say that this arrow here goes through this line of action, goes through, and we're going to move, just going to transfer this. So it looks like this, and this becomes our F1. Now it's on the other side of this point A, and we can do that because that's a law that says we can use any line of action in statics, and we can move this vector along that line of action and still get the same result. Next, what we're going to do is we're going to, this is F1. Then we're going to put F2, and what we're going to do is we're going to move this off of point A, but we're also going to move this head here, then this tail for F2 and this head of F1, and we're going to connect them, and this becomes still F2. Well, we can do that because basically what we're going to do is, don't think about this as physical space. This is a force space. So basically what we want to do is we want to add the two components to get this resultant vector. We're going to call that R. Now there's multiple ways to do this. Again, we can start to add the component, the x and y's together. That's one way to do it. But we're going to do, and this should look like a triangle now, with this theta at 30 degrees. So what we want to do is we want to use what's called the law of cosines. And again, sometimes this is so useful if we're just trying to figure out this R and this magnitude of this R. So one thing we can do, if we remember the law of cosines, it says c squared is equal to a squared. Oops, sorry, not AB. A squared plus b squared minus 2ab, the cosine of the opposite of this, and let's call this gamma for now. So this is what's called the general equation. We want to apply this equation over to this, this problem here. So what we can do is, since we know this angle is the opposite of what we're trying to find, and that's what we're trying to find is R. So what we can do is we can rearrange this to come up with R squared, that's what we're trying to find, is equal to now A squared, which is one of the legs of this triangle. So we can say that the force 1 squared plus the force 2 squared minus 2 times the force 1 times force 2, the cosine of this theta here. So that's how we can solve for R. It's as simple as that. We do not have to break up the F2 and any components. We just have to know the angle between the two vectors here. And you could do this on a multiple, there are ways and methods to do this for multiple forces, but for right now, this seems to be the best way to do this for this. So if we rearrange this, and we can say that R is equal to the entire square root of F1 squared plus F2 squared minus 2 f1 times f2, the cosine of that theta. You should get a magnitude of 62 newtons. Another way to do this, again, you can break this up. And basically what we did is we vector added. So if we take the vectors, r is equal to f1 vector plus f2 vector. We started with that, but we used the law of cosines. So we used the law of cosines to add these multiple vectors together, which you'll get us. It's a good way to solve some problems. Not all problems, but it's a good way to solve, and it's another tool in the tool chest. Well, have a great day, and we'll see you soon.